Okay, so I'll explain again. So what do you mean by this Green's theorem is? So Green's theorem here I have written. The statement is, let m and n be any two functions defined over and reason defined over defined over an area A in xy plane bounded by a simple curve C. Then this is m dx integration over curve C m dx plus n dy is equals to, it can be written as double integration over a area A dou n by dou x minus dou m by dou y into dx dy. So this we call, that is a Green's theorem. Okay, in a similar way, the Green's theorem can also be written in what, that is vector form. Vector form is how, that is if f is equals to mi plus nj, then equation 1 can also be written as, that is f dot integration over curve C f dot dr is equivalent to what, that LHS of equation 1. Okay, and which is equal to double integration over area over an area A curl f dot k into dA. dA means what, that is dx dy, that one can very easily understand. So curl f dot k, which yields, that is dou n by dou x minus dou n by dou y. So therefore equation 1 and equation 2 both are one the same. That means either you can use equation 1 or you can use equation 2, okay, according to your that is what requirement in the example. So therefore this is the what the statement of Green's theorem. Now we are seeing, that is example. So now example 1 is using Green's theorem evaluate y integration over curve C y minus sin x into dx plus cos x into dy, where C is the plane, C is the plane triangle enclosed by the lines y is equals to 0, comma x is equals to pi by 2 and y is equals to 2 by pi into x. Okay, so this is the example. Yes, so now we'll go to the solution of that. That is what they have given. So this they have given. If you compare this with, that is what the LHS of this equation 1, then you will get to know that what is m and what is n. They said evaluate, so that's why you can use this RHS and you can very easily evaluate the given particular example. So now first we'll write what they have given. Let C let integration over C y minus sin x into dx plus cos x into dy. We can call it equation 1. Okay, here what is m? Here m is equals to y minus sin x. Okay, one can very easily understand, this is m dx plus n dy. So m is y minus sin x, n is cos x. Okay, so now here n is equals to, that is cos x. Yes, so now what we want, that is dou n by dou x we want and dou m by dou y we want. So therefore here I'll write, that is dou m by, that is dou y. That means differentiation of this m with respect to y we are doing. So differentiation of y with respect to y is 1 and sin x is 0. So one can very easily understand this. So this is 1. Now this is dou n by dou x. With respect to x we need to what, integrate this. That means n we are integrating differentiating with respect to x. So therefore cos x becomes, differentiation of cos x is minus sin x. So see, differentiation of m is 1, differentiation of n is minus sin x. Okay, and that so we have written here. Now next is given, we will write, okay, what lines they have given and what is the geometry of it, right? So given lines are x is equals to 0, sorry, y is equals to 0, x is equals to pi by 2 and y is equals to 2 by pi into x. So just you draw them. Yes, this is x-axis, this is y-axis, right? And this is origin O, we can say. So y is equals to 0. Y is equals to 0 means what? Which curve? That is y is equals to 0 is, that is x-axis. So this is y is equals to 0. Next, x is equals to pi by 2. Somewhere you can represent x equals to pi by 2 means what? X value is pi by 2. So this means which is parallel to y-axis. Okay, at x equals to pi by 2. Somewhere here I'll draw. Yes, somewhere here I'll draw this as what that is. X is equals to, that is pi by 2. So this is x is equals to pi by 2. So now one more line is there. Okay, so this we will be calling as y is equals to 0. Okay, x-axis is y is equals to 0. Now y is equals to 2 by pi into x. Don't worry, first you put x equals to 0. Then what is y value? Y is also 0. Therefore, one point that will be here. That is, it will be passing through origin. So if you put x is equals to 1, then y is equals to 2 by 5. Somewhere here, so it will be passing through origin. Okay, it will be passing through origin and it will move like this. Okay, and equation of this is here only. Okay, here only it is there. So this equation of, that is equation of this line is y is equals to 2 by pi into x. So we get. So now what is this point? Okay, this point of intersection we want. Okay, this is origin O, we can call, this is A and this is B, you can say. So here A one can very easily understand. Y coordinate on x axis, y coordinate will be 0, but x is what? That is pi by 2, they only given, that is therefore we will write pi by 2 comma 0. That means the coordinates of A are pi by 2 comma 0. Similarly, what are the coordinates of this B? Yes, one can very easily understand, that is x coordinate is pi by 2 only, but what is y coordinate? Put pi by 2 here. Okay, put pi by 2 here. 2 by pi into pi by 2. Pi get cancelled, 2 get cancels. What you will get? That is 1. So that B, the intersection of that x equals to pi by 2 and y is equals to 2 by pi into x is pi by 2 comma 1. So this can this one can very easily understand. Yes. So after this, already we have found dou m by dou y, dou n by dou x also. Now we will apply, that's what Green's theorem. By Green's theorem, by Green's theorem, we have integration over curve C, m dx plus n dy is equal to double integration over an area A. And what is that area? The bounded area is this. Yes. So this is area A. So here we'll write dou n by dou x minus dou m by dou y into dx into dy. So now rewrite it, because m value we know, n value we know. Okay, dou n by dou x is there, dou m by dou y is also there. So now just you rewrite it. Integration over a curve C. Here what is that? M is y minus sin x into dx plus n is cos x into dy, which is equal to double integration over an area A. Double integration over an area A. Dou n by dou x value is, that is minus sin x minus dou m by dou y value is 1, that is minus 1, will be writing into dx into dy. Okay. So now here dx dy are there, therefore by replacing this A we need to write, that is limits of x and y. So therefore here in the next step, so here I'll say by the figure we can see x varies from, by the figure we can see x varies from x equals to 0 to x equals to how much? See, 0, 0 to pi by 2, 0. That means x is varying from x equals to 0 to x equals to pi by 2. X varies from x equals to 0 to x equals to pi by 2. And y varies from, yes, y varies from y is equals to, okay. So now y is varying from y is equals to 0 to y is equals to, that is 2 by pi into x. So y is equals to 0 to y is equals to 2 by pi into x. So therefore integration over curve C, y minus sin x into dx plus cos x into dy is equals to, x is varying from x equals to 0 to x equals to pi by 2, and y is varying from y is equals to 0 to y is equals to 2 by pi into x. This is minus sin x minus 1 into dy first, because here I have written y, so therefore first I'll write dy into, that is dx. Now start evaluation. X equals to 0 to x equals to pi by 2. Yes, that is derivative of minus sin x with respect to y is minus y sin x minus y into, that is dx, and y is running from y is equals to 0 to y is equals to 2 by pi into x. So now that minus sign will take it outside, okay, because minus sign is there, so we'll keep it outside. Here integration from x equals to 0 to x equals to pi by 2 will write. Now by putting y is equals to 2 by pi into x, so what we'll get, that is 2x by pi into, that is sin x, and here it is plus 2, or else minus sign you can keep it there only. So once again we'll take it outside, 2 by pi into x, and for a lower limit that will be 0, not necessary to write, into dx. So now here integration over curve C, y minus sin x into dx plus cos x into dy, which is equal to 2 by pi is common in these two equation, minus 2 by pi, I'll take it outside. So integration over x equals to 0 to x equals to pi by 2, then here it will remains x sin x minus x into, that is dx. So now we need to go forward, that is integration by parts in the first term. Yes, of course we have to yes, integration by parts we need to do in the first step, okay. So minus sign I have taken common here, so therefore here I'll write plus, that is minus 2 by pi, okay, integration first function into second function. That first function is x, you can keep as it is, x into integration of sine is minus cos, so therefore here minus I'll write minus cos x plus minus sine, minus of minus plus we'll get. Next derivative of x is 1, okay, derivative of x is 1 into again integration of what, that is minus cos x is, that is sin x, minus of minus, that is plus, so therefore here it is sin x plus, this is x square by 2, because integration of x is x square by 2, and limit are from x equals to 0 to x equals to pi by 2, okay. So which is equal to, now minus 2 by pi you can keep it outside only. Now put x equals to pi by 2, minus pi by 2, and here it is cos pi by 2 plus sin pi by 2 plus pi by 2 whole square divided by 2, and for lower limit that will be 0, leave it. So here we'll get minus 2 by pi in the bracket, cos pi by 2 value is 0, so therefore this first term is 0, minus 0 plus sin pi by 2 value is 1 plus this becomes pi square by, this is 4 into 2, that is 8, pi square by 8. So now so here you will get, that is minus 2 by pi in the bracket 1 plus pi square by 8. So this is the final answer of the first yes, 1 plus pi square by 8 minus 2 by pi, that is correct. So if you want to multiply it inside, then you can multiply it. So here you will get minus 2 by pi plus 2 by pi into pi square by 8. 2 ones are 2 fours are here, 5 ones it cancels. So now here you will get 5 by 4 minus 2 by pi as an answer. Okay. So here integration over curve C, y minus sin x into dx plus cos x into dy. So this is a final answer. Okay. So this is the first example. Now I will go to next example. Example number 2. Example number 2. Evaluate integration over a curve C, x square minus 2xy into dx plus x square y plus 3 into dy around the boundary of the region defined by y square is equals to 8x and x equals to 2 by Green's theorem. Right? Okay. So let me solve it. Solution: let f is equals to integration over curve C, x square minus 2xy dx plus x square y plus 3 into dy. You can call it equation 1, right? Here what is m? M is, one can very easily understand, m dx plus n dy. So therefore m is x square minus 2xy and n is x square y plus 3. Then what is dou m by dou y? With respect to y we have to differentiate this. X square is 0, minus 2x will be constant. With respect to y, if you do, then here you will get minus 2x. Then then dou n by dou x. With respect to x we have to differentiate partially. Therefore y will be constant. Then here you will get 2 times xy and derivative of 3 is 0. Okay. Next is what they have given, we need to write. So here they have given around the boundary of the region defined by y square is equals to 8x and x equals to 2, they said, right? So now given that, we'll write given curves are y square is equals to 8x and x equals to, that is 2. So now we'll draw a diagram for this. This is x-axis, this is y-axis, this is origin O. Y square is equals to 8x, it will be like this. Okay, y square is equals to 8x, it will be like this. So here I'll say this is y square is equals to 8x. Okay, then next x equals to 2. You know that x equals to 2 means what? That is x equals to 2 means which is a line parallel to y axis. So therefore it is x equals to, that is 2. Okay. So now, given area is defined. Okay. So therefore, now the pointers. Actually, these are the two lines. Okay. X equals to 0 is one line. Okay, and x equals to 2 is another line. Okay. That's what horizontal compartments are fixed. But this whole area is there. This whole area will be there to what, that is integrate. So therefore, what is this lower curve, what is its equation, and what is this upper curve is? Okay, its equation is y square is equals to 8x. But if you solve it, then what you will get? Y is equals to plus or minus square root of 8x you will get. So that's why this lower curve, okay, from this point to up to this point, so this will be y is equals to minus square root of 8x, and from here to here, so this will be y is equals to plus square root of 8x. This is minus square root of 8x, this is plus square root of 8x. Okay, so this is what that is given the fact. So now we'll write that's what the definition of that is Green's theorem. Okay. Yes. Now by the Green's theorem, by the Green's theorem, we have integration over m dx plus n dy over a curve C is equals to double integration for an area A dou n by dou x minus dou m by dou y into dx into dy. So now put m and n. Okay, here m is there, n is there, dou m by dou y is there, dou n by dou x is there. So integration over a curve C, m is x square minus 2xy, x square minus 2xy into dx, n is x square y plus 3 into dy, which is equals to double integration over an area A, dou n by dou x is 2xy minus dou m by dou y is minus of minus, it is plus 2x, that is plus 2x into dx into dy. Okay, yes, so that is right. So now we need to allocate, that is what, limits for x and y. So therefore okay, so now yes, by the figure we can see x varies from, one can very easily understand. Okay, x is equals to 0 to x equals to 2, x varies from x equals to 0 to x equals to 2, y varies from, that means what, the vertical the lines, okay, which will be the constant for us, right? So therefore x equals to 0 to x equals to 2 is done. Now that is horizontal, we need to see from here to here one line, from here to here another line. That means what, y is equals to minus square root of 8x is lower curve, and y is equals to plus square root of 8x is upper curve. So therefore y varies from y is equals to minus square root of 8x to y is equals to square root of 8x. Therefore integration over curve C, that is x square minus 2xy into dx plus x square y plus 3 into dy is equal to double integration, that means first integration that is x equals to 0 to x equals to 2, and the second integration is y is equals to minus square root of 8x to y is equals to plus square root of 8x, and here we have 2xy plus 2x into dy into dx. Okay, so that is equal to, now integration x equals to 0 to x equals to 2. Now integration of 2xy with respect to y, that is 2x is constant and y becomes y square by 2. So therefore 2xy square by 2 plus this is 2xy into dx. Here limits are y is equals to minus square root of 8x to y is equals to plus square root of 8x. Okay, which is equal to, this 2 get cancelled. So now put upper limit, then integration from x equals to 0 to x equals to 2, x into, that is root 8x square plus 2 into x into square root of 8x. Okay, yes, so this much we'll get. Next, minus for lower limit, this is for upper limit. For lower limit, for negative sign we need to put. So actually minus root 8x is there, but square it is square, so therefore here we'll get x into minus root x whole square. Again this is minus 2x into minus root x. Okay, 2x into minus root x into, that is dx. It will get into dx. Okay, so now integration over curve C, that is x square minus 2xy into dx plus x square y plus 3 into dy, which is equal to, you can see now here these two, if you get, so here this negative will not be there because square, that's what whole square is there, this negative will goes, so therefore these two get cancelled. Yes, so now here we'll get x equals to 0 to x equals to 2, that is 2x into root 8x, yes, minus of minus, this is plus 2x into root x into dx will get, which is equal to integration from x equals to 0 to x equals to 2, this is 2 times means what, here we'll get 4x into root x into dx. That means 4 into root x, root 8 you can keep it outside, and integration from x equals to 0 to x equals to 2, here we'll write x to the power 3 by 2, because x to the power 1, root x means what, 1 by 2, that means x to the power 1 plus 1 by 2, x to the power 3 by 2 into dx will get, which is equals to 4 root x, integration of x to the power 3 by 2 is integration of x to the power plus 1 means it is 5 by 2 divided by 5 by 2, and x is from x equals to 0 to x equals to 2, that is equals to 4 into root 8, this is 2 by 5, x to the power 5 by 2, and this is x equals to 0 to x equals to 2, that is 4 root 8 into 2 by 5, then it will be here 2 to the power 5 by 2, 2 to the power 5 by 2. So final answer now here is yes, the final answer here is 128 by 5. Okay, so this is 128 by, it is 5, and here you'll get integration over curve C, x square minus 2xy dx plus x square y plus 3 into dy is equals to 128 by 5. So this is a second example. Similarly, we'll see one more example, and that is simpler than the previous two. Yes. So example number 3. Yes, example number 3. Evaluate integration over curve C x square plus xy into dx plus x square plus y square into dy, comma, where C is the square formed by the lines x equals to plus or minus 1 and y is equals to plus or minus 1 by Green's theorem. Okay, this is a simple example. Solution: let integration over curve C x square plus xy into dx plus x square plus y square into dy, call it equation 1. Yes, here m is equals to x square plus xy, n is equals to x square plus y square, that is dou m by dou y is equal to x and dou n by dou x is equals to 2x. One can very easily understand this, right? The partial derivative of m with respect to y, so this will be 0, so derivative of y is 1, so therefore x will remain. Partial derivative of n with respect to x, that is x square derivative is 2x and y square is 0, right? So now given lines are x equals to 1, x equals to minus 1, y is equals to 1, y is equals to minus 1. Okay, plus or minus 1 means what? X equals to 1, x equals to minus 1, plus or y is equals to plus or minus 1 means y is equals to 1 and y is equals to minus 1. Now we'll see the figure of this particular the lines. X axis, this is x axis, this is y axis, origin O. So now here this is the line x equals to 1, okay, that is parallel to y axis. Next, x equals to minus 1, again that is what, parallel to y axis but at x equals to minus 1. Yes, so this is x equals to minus 1, right? Next, y is equals to 1. Y is equals to 1 means that is a line parallel to x axis at y is equals to 1. Okay. Yes, so this is y is equals to 1. Yes, so now y is equals to minus 1, again that is parallel to x axis at y is equals to minus 1. Now, so it has formed square, okay, and it is here. We can see this. Yes. So this is a square formed by these four lines. Yes. And this is origin. Oh, you can see. So here I'll represent. This is x-axis. Sorry, y-axis. This is x-axis. Okay. So now here x will be varying from x equals to -1 to x equals to +1, and y will be varying from y is equals to -1 to y is equals to, that is, +1. So very simple. So now go for, that is what definition of Green's theorem. By the Green's theorem. By the Green's theorem, we have integration over a curve C m dx plus n dy is equals to double integration over an area A dou n by dou x minus dou m by dou y into dx into dy. Now put the values. Integration over a curve C, m is x square plus xy, x square plus xy into dx, plus n is x square plus y square, x square plus y square into dy, which is equals to integration over an area A. Dou n by dou x value is 2x plus x into dx into dy. That is nothing but integration over an area A. 2x plus x is 3x into dx dy. Okay. So now by the figure we can see x is varies from, yes, we can see x varies from where to where? X varies from x equals to -1 to x equals to +1, and y varies from y is equals to -1 to y is equals to +1. Okay. X equals to +1 to x equals to x equals to -1 to x equals to +1, from left side to right side, and from bottom to so from downward to upward. So y is equals to -1 to y is equals to +1. Okay. Yes. Therefore integration over curve C x square plus xy dx plus x square plus y square dy is equals to x is from -1 to x is equals to +1, y is from -1 to y is equals to +1, 3 times x into dy into dx, which is equals to x equals to -1 to x equals to +1. 3 I'll keep it outside. Integration of x is x square by 2, y is from -1 to y is equals to +1 into dx. Okay. Hope this answer will be 0 because of what, that is odd function. Yes, it is odd function, so therefore answer will be 0. That is 3 in the bracket x equals to -1 to x equals to +1, by putting upper limit 1 by 2, by putting lower limit 1 by 2 into dx. So therefore what you will get, 3 into integration over x equals to -1 to x equals to +1, this is 0 into dx. So therefore whole answer is 0. Therefore integration over a curve C, that is x square minus xy into dx plus x square plus y square dy is equal to 0. The answer is 0. Yes. So this is the third example. One more last example is there. That is, it is little bit different. That they said verify the Green's theorem for the given example with someone. Verify means what? What here you need to do is whatever LHS and RHS you people will get. So in these 3 examples we have taken this that's what RHS, and we have found the answer. If they said verify, then what you need to do is you have to find the answer by using LHS. That means what? M dx plus n dy. Okay, by using this also you have to find the answer. Okay, and keep the answer. And next by using RHS also you have to find the answer. And next you have to compare both the answers. If both are same, then that's what the Green's theorem will be verified. Yes, so that one example is there, and that solution is also given in the notes. You can see that, and I can very easily do, because for the first for this LHS you can use line integration, okay, and for RHS it is what, that is double integration, okay. So one can very easily do, because both line integration and double integration you people have learned, and on double integration already I have evaluated 3 examples, and on line integration also we have we seen many examples. So therefore you can do that 4th example, that is verify the Green's theorem, right. So now 2 more concepts were left in that 2 more concepts were left in the in this particular unit. So now that first I'll take up that is Stokes theorem, right. Stokes theorem, it's a statement without proof, and examples on this Stokes theorem, okay. So today, in the today's class, another 10 minutes is there, so I'll define the Stokes theorem. So how the Stokes theorem is there, and next, that is its examples. Stokes theorem. Statement. If yes be an open surface, F be an open surface bounded by a closed curve C, bounded by a closed curve C, and vector field F is equals to F1I plus F2J plus F3K. B any continuously differentiable vector field or vector point function. Continuously differentiable vector point function, then integration over a closed curve C, F dot integration over a closed curve C, F dot dr is equals to double integration over a surface S, curl F dot n cap into ds. F into ds, where n cap is that you know, where what is n cap? N cap is unit n cap is unit external normal vector. External normal vector to the surface, yes, to the surface, yes, right? So this we call, that is that's what the Stokes theorem. Very simple, guys. You can see here f dot dr over a closed curve C, that is equal to the double integration over a surface S curl f dot n cap into ds, right? So what is the main difference between the previous that's what Green's theorem and this Stokes theorem? Very simple, that Green's theorem is for that is plane. So we have seen that Green's theorem in a, that's what, plane, xy plane, but this Stokes theorem is for, that is, it is for space. You can see here everything is same. F dot dr was there, okay, integration over a closed curve, f dot dr was there, curl f was there, okay, in a vector form. You people have seen n cap dot ds was there, right? So here n cap in that previous case is n cap is what, that is k, okay, because if it is a xy plane, that is unit external normal will be like this, so therefore that will be along a z axis, so therefore we have written there k. And ds, you people know, so ds if you project that's what the surface element on xy plane, then what you will get, then ds is equals to dx dy divided by n cap dot k cap. So n cap dot k cap, and if n cap is what, that is k cap dot k cap value is 1, so therefore, so this is a generalization of what, this particular what equation, okay, or this particular what the theorem is generalization of, that is Green's theorem, okay. So therefore, so here one more point I need to tell you. If S be an open surface bounded by a closed curve, open surface bounded by a closed curve means what? For instance, if you consider sphere, right? Sphere will be what, that is a closed surface which is not open. If you cut it, right? If you consider, that's what, the hemisphere. Yes, if you consider, that is hemisphere. Yes, so this is a what, that is hemisphere, not a full sphere. If you consider full sphere, then that is a closed surface, that is not an open surface. If you consider, that's what, hemisphere, then this is open surface, because here it is open. Okay, here they said if S be an open surface bounded by a closed curve C, then where is the closed curve? Which binds it? The closed curve is this. Yes, so this is a closed curve. Yes, so we will be calling it as what, that is C. So just you take a ball and cut it. So whatever the that's what the circle you will get. Yes, so that is what the closed curve C, right? So therefore, here they said bounded by, that's what, closed curve C, and this remaining thing is what, that is as well as what, that's the previous Green's theorem. So therefore, this is the statement of that is Green's theorem. Now, if you do examples on this, if they said evaluate, that's what, the given some example by using that Stokes theorem, then you need to find a curl f, okay, curl f, n cap and ds, okay. So finding curl f is only the extra thing, okay, and you know here how to find a curl f. So curl f can be found, curl f can be found like this: determinant I, j, k, dou by dou x, dou by dou y, dou by dou z, and here it is f1, f2, f3. Yes, if you elaborate this by finding out what the determinant value of this, you will get curl f, and n cap, you know how to find n cap, that is vector n. First you have to find, that's what, grade of, that is gradient of that's what, the given curve, okay, gradient of what, that is given surface you have to find. So next, n cap can be found, n cap is equals to vector n divided by modulus of vector n. Yes, so like this, if you find these two, and one more the fact, that is ds. If you project it on xy plane, then ds will be dx divided by modulus of n cap dot k. Yes. So like this, you can very easily find curl f, okay, n cap, and that is ds. Therefore, one can find the answer by using that is Stokes theorem, right? So the remaining the examples on this we'll see in the next class.